Hello, the goal of this video is to give you a quick introduction to using Microsoft Excel to do a spreadsheet analysis. You have a homework assignment coming up where you need to use a spreadsheet to do your water balloon launcher analysis, and I'll walk you through a couple of the basics for using Microsoft Excel in terms of calculations and formatting as well. So the first thing I'll do is put in some of the constants for our problem here at the top of our spreadsheet. So we'll keep track of the diameter, number of tube pairs, the spring constant, pounds force per inch, the launch angle in degrees, the balloon and bucket mass in pounds mass, and the total system efficiency, which we talked about as the loss coefficient. If I want to make these fit into my column, I can drag or just double click here on the right of the column header, and it expands to fit them automatically. Now I can type in my actual constant values, so 3 inches, 3 tube pairs, 0.34 pounds force per inch, 45 degrees, 0.258 pounds mass, and 0.119 for my total system efficiency. Let's say I want to calculate how far my piston will actually move for a given pressure. So I can create a heading here for pressure in PSI, and I can also create a heading for the piston stroke in units of inches. If I want the word piston to be subscript, I can double click to edit the cell. I can highlight the word piston, and under my formatting ribbon here at the top I don't have a subscript button. Under font, however, you can click on this bottom right button to bring up more detailed formatting options, and there's a button for subscript. Okay, so I've got that. If I want to justify those to the right, I can highlight the cells and use this button to align the text accordingly. So let's say I've got 18 psi of pressure and I want to know what the piston stroke is. Well, as we showed in class for that sort of Model A sling type thrower, the piston stroke turns out to be a function of pressure times the piston area divided by 8 divided by the number of tube pairs divided by the spring constant. So to calculate that formula in Excel, I always start with the equal sign. First thing I want is pressure, and so I'll just click on the cell that contains pressure, and you see it's brought in as a reference cell or column B, row 11. Next I want to multiply by the area. I'll put that in parentheses here. The area of the piston head is pi times the diameter squared divided by 4. In Excel, the shortcut for pi is the word pi, pi, with a open and closed parentheses. Don't ask me why, it just is. Next, I'll multiply that by the diameter squared, so caret symbol 2, and I'll divide by 4. Okay? From here I need to divide by 8. I also need to divide by the number of tube pairs, and I need to divide by the spring constant. I can hit enter now, and there we go. I've got 15.59 about inches. Now this is an important point about Excel. It does not keep track of units. So you always want to keep track of sample calculations by paper, one of each type of calculation, to ensure that one, you're doing the calculation right, and that also your units are correctly what you think they are. You have to take my word for it here. Let's say I want to show less decimal places. That's a little excessive. Well, there are two ways to do that. One, you can right click, format cells, and under number choose the decimal places. Another option is under your ribbon you have number formatting options, and I can increase and decrease decimals. There we go. One of the nice things about Excel is it allows you to do a lot of repetitive calculations without having to retype formulas. So let's say, for instance, I want to calculate the piston stroke for multiple pressures. Let's say I'll start out at 10, 15, and let's go a few others. Well, there's a pattern here, and usually Excel can find it. I can highlight the two, click on the bottom right, and drag down. Yep, it caught 20, 25. Now let's say I also want to do repetitive piston stroke calculations. Well, there's something I need to do first. I'll double click to activate the cell formula. And note that I want it to update the pressure cell, but I want it to always use the same three constants at the top here. The word is I want to anchor those cell references. And to do that, you put a $ in front of the row and column. So I'll do that for my three constant parameters, and I'll leave my piston or pressure reference as it is. I hit enter and nothing changes, which is good. But now the nice thing is you can either click on the bottom right and drag down, or you can just double click and it fills it out automatically. I can double click here in this cell and see that yes, it has kept my constant references, but it has updated the pressure accordingly. Very nice tool with spreadsheet analysis. You also have other calculations to perform, and one of those involves using trigonometric functions. I want to point out one thing about that. Let's say, for instance, and I'll just work up here, you want to calculate the sine of your angle. Well, you might type equals sine and then choose your launch angle placeholder. But you end up with a number that's not equal to the square root of 2 over 2, which is what we would expect for the sine of 45 degrees. The issue is, again, you've got to be careful with units in Excel. It turns out that Excel, when you use trigonometry, is expecting to see the argument in radians, whereas we have the argument here in degrees. So to fix that, we're going to have to convert it. We know that there are 2 pi radians for every 360 degrees, or pi radians for 180 degrees. So I'll take my C5 reference in degrees, and I'll multiply it by pi radians divided by 180 degrees. That'll cancel the degrees and make my argument now in radians. And when I hit enter, I see that I correctly have square root of 2 over 2. So be aware of that when you do your analysis. Another thing you should probably be aware of is creating nice borders. To do that, for instance, if I want to put a nice border around all my data, I can highlight those cells, and then under font I have a border selection tool. I can choose the drop-down list and all sorts of options here. I'll choose maybe a thick box border. Let's say I want to put a border here too. I could highlight those cells, go back to my drop-down list, and maybe pick a bottom double border. Okay, so you could play around with that and choose all types of custom border options. One final thing is how do we print this for turning it in as a deliverable? Well, the first thing you want to do is tell Excel what part of the page you want to print. So we'll highlight our information of interest, and I'll go up to Page Layout, and under Print Area, I'll set that. You see that now you've got a dotted or dashed line to indicate that it understands this is the region that I'm interested in printing. I can now go to File and choose Print, and you see that it brought that in. Now, a couple things to note. One is, let's say you have a rather large table and it's running over into multiple pages, but you want to fit it in on one. Well, you can click on the scaling options here and fit the sheet onto one page, and that'll reduce the size of it to make it fit on one page. You can control your margins, you can control the size of the piece of paper, whether you have portrait or landscape orientation, all those things. We can also, let's say I want to center this on the page. Page Setup has some more detailed options. There we go. So here under Margins, it's sort of hidden, but you can choose to center on page horizontally and vertically. Also, if you wanted to put a header and a footer in on the top and bottom of your page, you could type information there as well. There we go. It's now centered on the page, and from there I could print if I wanted to. For me, I'll go back to Home, and that should give you enough information to be dangerous enough to do a spreadsheet analysis with Microsoft Excel for your homework problems. Thanks for your time.